Let's begin with the given problem. Hello students. So we will be solving now based on this the part related to buoyancy, and of course related to which we include the buoyancy and density, buoyancy and Newton's laws along with the various the Archimedes principle also. So problem is based on this specific three parts. See subparts here. So see the problem. 1 into 10 raised to 3 kg cube of aluminum. This is a placed. It is placed in a tank. When water is added to tank, only half the cube. So half the cube is immersed. What is the normal force on this cube? This is the A part. This is A part. Here we have to find what is the normal force on the cube. And this is the B part. B part, mercury. Now in B part, what is happening? Mercury is introduced. This mercury part is introduced. A G there. So mercury is introduced and slowly poured into tank. Normal force. Now this normal force is goes to zero there. So question is that how deep is the layer of the mercury here? So let's solve. Interesting one and easy one. So first we'll begin with this part here. So first part what we have to do, what we'll be doing here, we'll be finding the force here. Find the normal force. You have to find the normal force on the cube, and you have to calculate the volume of the cube. So as usual, volume one. This is for aluminum. This will be for volume of aluminum. Aluminum. There, volume of aluminum, mass upon the density, mass of aluminum upon density of aluminum. Substituting the values, you will be getting this answer 0.370 meter cube. Now, density will be one third of its volume. One third means cube root. Remember, volume of cube is L cube, so L will be cube root of V. So, in a simple words, I'm taking one third of that. So, using this one log table or calculator, I'm getting this value as 0.718. That will be your height. That is what we'll be getting H. Remember the height, length, breadth, height. That is going to give you the height of this cube. Length of the cube that is equal to height there. Okay. Now, what is the next part that we have to solve here? Now, according to Newton's second law for the cube, n minus m of a, the mass into gravity, we are using the reaction and the normal reaction, normal force there is minus mg, that is the weight of the block into gravity, weight of the block, mass into gravity, sorry, and plus the buoyancy of the water, the buoyant force. This is the buoyant force equal. The buoyant force is equal to weight of the displaced water. This is Archimedes principle, you know. Archimedes principle there. So using this, we will be finding is equal to 0. Now n is equal to similarly. How will be getting m1 as usual the weight of the aluminum block minus we are subtracting this one the water and we are transposing on left hand side minus the buoyancy force given by the water. So mass into weight as usual. Now what is the buoyant force? Buoyant force will be density into volume. Remember, and this volume what will it will be half of that. Volume will be v by 2 there. Okay. Why half? Can you tell me why this half is there? Because it is the if one water is added to tank. If you'll observe in the original question, if you'll observe this one. So if you'll observe what they have mentioned, it is a half the cube. The mentioned part is half of the cube. It was. So half volume we are considering here. We'll be considering a half volume in this case. Okay. So we are continuing this part here. So half volume, so half volume V by 2 into G. Now substitute the values here. 10 raised to 3, 9.8, 1 into 1, 10.3. And using log table calculator, you'll be getting these values. 9.8, 10 raised to 3 minus 1.8 into 7.99. So this is what we got the second law, the force. Now next part. Now next part goes with what is expected or calculate the level H of the mercury. Now we'll be applying Newton's second law. This is regular. Since n equals 0 for the buoyant force, and we'll be using as usual n into aluminium, the same mass into weight of the aluminum block here plus the buoyancy from buoyant force of the water. Now this part is additional part. I'll highlight this in different colors. See, this is what we are having the additional part. That is the mercury is added in this case. Added mercury. H of the level H of added mercury here. So this part will be added. So just one, what is this? This BHG, the buoyant force given by the mercury will be rho, density of mercury, area A into H into G. So volume into area into gravity, that will be the force applied. So this will be so what will final answer? The mass and weight of the aluminum block minus the force buoyant force of the water. So that is equal to 7.93 into 10 raised to 3 that we found in the last safe part. Now how will we find the h height? Height will be getting in this way. H will be equal to the mass of helium minus band force of mercury divide by, we are dividing it with the density of mercury into the area A of gravity, A into G, the area multiplied by area. Now here in this case the what area will be there? Area will be what we got H. If you remember, H we got 0.718. That is the length of the cube what we got. Now area will be H square or length square. That will be H square, right? So will be using the density of mercury that is given in the table or it is provided in the question. This we got already in this question. Now we are squaring this. What we are doing? We are squaring this part, so that will be our area part, and this is our G, this is our natural G. So this will be your area, this is what we are having, this is your density for the mercury, this will be rho density for mercury there, and multiplied by area. On solving this you will be getting this answer, H is equal to 0.116. So that is the final, that what you want, the height will be 0.116. Okay, thank you.